This is Radio TV Phononut and Bad Camera Productions presents a Philco Model 37-93 Cathedral radio from 1937, as indicated by the first two digits of the model number. Actually, Philco had two other models that used the same cabinet. One, I believe, was the 37-84. It was a 4-tube superhet and really wasn't that good of a radio, basically city reception only. And then there was a battery-operated 4-tube version. So this 5-tube AC version is the best one of the bunch. And this one is in exceptionally good shape. Even the photo finish front here, it's made to look like some impressive veneer, is in good shape, which it's usually not. Really, all this cabinet's going to need is a good cleaning and polishing, and it'll be good to go. Here's the back. Even the chassis looks to be in relatively good shape. No major rust problems or tarnish, so I suspect this radio has spent its lifetime in somebody's house. I don't think this has been sitting in a barn or a damp basement or an attic for the past 50 years. Okay, I can see that someone has replaced the audio output transformer, but it was done a long time ago based on this tape here. It doesn't look like a recent splice job. And the power cord's been replaced. I don't know what else may have been done. We'll know that when we pull the chassis out. Let's connect an antenna to it and bring it up carefully and just see what happens. Alright, starting it out at about half voltage. Let's turn it on and see what happens. Bad filter capacitors right off the bat. I'll let it warm up a minute and bring it up slowly and see if we can get any stations. Squealing. That sounds like bad bypass cap. That he's so respectful doing, but the blessing does not come during. The blessing comes after, when we have been faithful. Yes, when I get to heaven, I will hear. Thy good, well done, my good and faithful servant. Amen? And then Alright, that's good enough. I don't want to leave it on too long like that. But at least we know all the major organs are good, or we wouldn't be receiving stations at all. But we can pretty much be assured right off the bat that the power supply filters are bad. That's the reason for the hum. And most likely some bypass capacitors are also bad. That's the reason for the squealing. Now let's pull the chassis out and see what we're looking at here. Okay, all three chassis mounting bolts are present, so that's a good thing. Seems like 90% of the old radios I find at least one of the chassis mounting bolts is missing. Sometimes they're all missing or mismatched or whatever, but these look to be all correct and matched, and that's a good thing. And in order to remove the chassis, we need this big honking 10mm driver here. Yeah, back in 1937, they used mounting bolts that are more substantial than an entire Crosley Cruiser is today, so just goes to show you how far down the toilet we've gone in the manufacture of radios and record players. Alright, here's the top of the chassis. You have some minor rust spots on the top of the chassis and the power transformer. Here's the speaker. It looks to be in nice shape. Well, you might remember about a year ago I had to glue down the bottom portion of the little flapper or whatever it is that covers the lens when not in use. Now the top portion has decided it's going to stay down all the time, so now we got to jake leg that. But yeah, I think it's about time for a new camera. I think I've about worn this one out. Well, one thing's for certain, my video is probably the only one on YouTube that looks like this. Alright, what I can see has been done. There's a tacked in 1940s era, maybe 50s filter cap here. And I can see where the old capacitor, they unsoldered it and taped the wire off with this old-timey electrical tape. This looks like a 3-section cap, I would say. And we know that's bad, and we know this replacement is probably bad too. There's a couple more 1930s era Sprague capacitors in here. Those may be original. And then we have a couple of these Bakelite block condensers that we're going to have to deal with. Okay, this capacitor is the AVC filter. It's a 0.05, and that's what the schematic calls for. This capacitor here connects from the plate of the output tube to ground, the plate bypass capacitor. The schematic calls for 0.006. They have a 0.01 installed in here, which is really not that critical. But first we need to address this filter situation. And based on the red sleeving that's over this filter capacitor and the red sleeving that's over these two Sprague capacitors, I'd say the same technician replaced all of them. And at least they bothered to disconnect the old capacitor section from the circuit. Alright, I have the old filter disconnected and I tested it just for grins and giggles. The section for the bias supply reads about 1 microfarad. The other two don't even read that much, so no wonder it was humming like a son of a gun. Now I'm just sitting here pondering how I've already installed one of them here, and I'm just pondering as to where I'm gonna mount the other ones. Now, if I wanted to be really classy, I could pull this can out, cut it open, and restuff it. But I want something that's going to be easy to service down the road should these capacitors fail. Now, I generally use high-quality parts, as in Nichicon and Panasonic capacitors, that should last a long time, but if 50 years down the road somebody needs to work on this, I want to make it easy for them. And you can see we have them in place. One of them I have connected here, and then the other two I have on a terminal strip up here. For the bias filter, I used a 250 volt cap, which is still plenty overkill because I'm measuring the bias voltage at that capacitor, and there's only 17 volts there, so that's plenty enough. And you can tell we're playing hum-free now with no squealing. Got to clean that volume pot.
Doesn't work that way on the ML.
I mean, we're getting some hum, but it's modulation hum. Let's turn the fluorescent light off and just see if I can get any distant stations. Yeah, there's a little country station about 35 miles away, so that's pretty impressive if it'll bring that in. Yeah, WHOC. But that's pretty impressive if it'll pick that up with no alignment, no further servicing than just changing the filter caps.
No, it's a team game, so I hate when people act like...
There's another talk station. It's about 90 miles away. And that's about it. So, turn our light back on and continue with the troubleshooting process. Alright, let's look at the control grid voltage on the audio output tube. Jumped up there to over 125 volts. Which it should not have done that. we have a negative 6.8 voltage, negative, I'll get it out in a minute, negative 7 volts on the control grid in respect to the cathode, which in this case is connected to the chassis of the radio. It's not as bad as it could be, but if that capacitor was blocking DC as it should, it wouldn't have jumped up to 125 volts there while the tube was warming up. So we need to replace that capacitor, which I do believe is encased in this Bakelite block here. Okay, the capacitor is indeed enclosed in this black Bakelite box here, and it connects from the two end terminals. I think this center terminal is just a tie point for other things. In other words, there's only one device inside of this particular block here. Okay, I've disconnected the capacitor from these connections here, at least I think I have. Now we need to undo this bolt here and lift the block up, and then I'm going to heat it up and pick it out and do whatever I have to do to get the old capacitor out, and then we'll just put a new capacitor inside of the original block. And when you do that, there's no need in filling the block full of any kind of tar or beeswax or anything like that. All you have to do is just poke the capacitor through the holes here, make the connection, solder it up, and it's good to go. You can see what it looks like before we heat it up. Now don't do what some service technicians do and just parallel a new cap across the terminals on the top of the box, because it looks tacky and you still have the leaky cap in circuit. So do it right, heat all this up, dig the old cap out, put another cap in, and solder it up. Alright, here are the old cap guts. Dug out all the old tar out of the box, which required some heat to help aid us get it out. And there's our replacement capacitor physically in place. And yes, I have the fall side of the capacitor connected to the plate of the first audio tube, which would be the lowest impedance point. Oftentimes it really doesn't matter, but there's some cases where it does, so better just to do it right. And in that way I won't be chasing my tail if some weird problem comes up later. Alright, the capacitor block is physically back in place. Now all we have to do is wrap these capacitor leads to their corresponding terminals, and then solder them up, and then cut off the excess leads, and this capacitor will be good to go. Alright, here we are back in place. Now let's flip it on and see what our control grid voltage is. See, it jumped up just a tad bit there and then come down. It didn't go up to 125 volts like it did before. And as you can see, we now have negative 13.5 volts there, so that'll make the tube much happier. Alright,
no doubt
good, good.
Good again.
Alright, we've still got our little country station, so nothing got worse. Alright, the next item of concern is this plate bypass capacitor that connects between the plate and the chassis. If it were to short, it could take out the audio output transformer and put a heavy load on the power supply. I have it disconnected. I have the ground end disconnected. We're going to turn it on and see if it passes DC through it. And I figured it would. Yeah, 150 volts, we'll just say. So yeah, that capacitor is mucho leaky. Plate bypass cap replaced. And that only leaves the AVC bypass in this block here, and one of them in this block is the line bypass. which could short. Okay, in this particular condenser block contains the line to ground capacitor and the screen voltage supply bypass capacitor for the IF and mixer tubes, and I'll show you that on the schematic right now. 0.01 microfarad from one side of the line to chassis. That's supposed to be for noise suppression. And then up here we have, let's see, where is it? Yes, a 0.1 microfarad from the screen grid of the IF and mixer tubes to chassis. And that's supposed to keep RF off of those screen grids. If that capacitor becomes defective, it can cause oscillation, which can result in squealing and motorboating and such in the speaker. If this capacitor becomes defective in a way that involves high leakage or a short, it's going to put a major strain on the power supply. And if this line filter capacitor here shorts, you'll have a hot chassis, and you don't want that. Now, while we're on the subject of this schematic, let's look at the filter capacitors. There were 3 of them in that can. 2 8 microfarads and a 10 microfarad, all having a common ground. The 2 8 microfarads are the power supply filters for the main B+, and our common ground connection for the filter capacitors involves connecting them to the center tap of the power transformer. But if we look over at this 10 microfarad, that's our filter capacitor for the bias supply, and this is where a lot of people get confused. You see one end of the capacitor connects to chassis ground, and then the other end of the capacitor goes back up to the center tap of the power transformer, which also connects to this voltage divider network. As you can see, we have a 200 ohm and a 70 ohm resistor connected together, and at the center of that 200 and 70 ohm, we got our bias voltage for the tubes up here, and then the end of this 70 ohm resistor connects to the chassis. Well, a lot of people make the mistake of thinking that the negative terminal of this filter capacitor here is what connects to the chassis, and that's wrong. Like I said, the negative terminal of this can capacitor, which contains the 3 capacitors, connects to the center tap of the power transformer, and the positive terminal of this capacitor connects to the chassis. And you want to pay close attention to that, because back in the 30s they had some pretty weird filter capacitor arrangements, mostly to obtain bias voltage for the tubes. In some cases, the filter capacitors would be common positive, and the field coil would be in the negative side of the capacitor. So you want to pay close attention to that, or else you might have a capacitor blow up on you. And here's the AVC filter, and its purpose is to keep unwanted RF off of the AVC line, because if that RF was present, that could cause all sorts of unwanted oscillation and undesirable effects that you don't want. Now, if this capacitor were to open, which they usually don't open, like I said, it could cause a lot of oscillation and squealing, and it could kill reception altogether. There's not enough voltage involved here to really pose a threat of anything going up in smoke if this were to short. But if this did short or become excessively leaky, it could load down the AVC circuit to the point where it wouldn't function correctly, and that could have an adverse effect on your reception. So we'll want to replace that. But I'll say this, it always amazes me, these old parts, even on parts that are hidden under a chassis that are not seen, they often went above and beyond with the graphics on such parts. Now the parts you get is pretty much like everything else. It's all plain Jane and nothing to it. So even though these capacitors are garbage from a functioning standpoint, they still have eye appeal to them. AVC filter installed, and yes, I jake-legged the camera. I have the top flap taped up, so we can use this camera until the other one shows up. Now it's time to remove the big capacitor here and gut it and replace the two internal capacitors. Now for the AC line to chassis capacitor, we'll use a 0.01 microfarad AC rated safety capacitor, and then we can use a regular film cap for the screen grid bypass capacitor. Now in this particular capacitor block, our 0.01 microfarad line bypass capacitor connects between this center terminal, which has the one leg of the AC cord tied to it, and this outer terminal here that connects to chassis ground. And our screen grid bypass capacitor connects from this extreme terminal to my left here, and the other end connects to the terminal to chassis ground. So when you're restuffing one of these, you want to make doubly sure you know what goes where, and the ability to read a schematic diagram will help you tremendously in that endeavor. Now before I gut this, I thought we'd check it for leakage just for the entertainment value. I'm first checking it for value, and I'm not getting any kind of well-defined eye opening here. So let's see at 20 volts. Now this is the AC line bypass capacitor. Yep, extremely leaky. 200 volts, even worse. And then as we get higher, it just shorts. So yeah, this would be a danger. Now let's check the screen bypass section. Here's the screen bypass section. Not getting a very sharp, well-defined eye opening there either as far as the value. Now, what about the leakage? Yeah. 20 volts and the light just stays on, so I think we're pretty much at the almost shorted stage. Here's the AVC bypass cap. Leaky as all get out, even at 20 volts. And the audio output tube plate bypass capacitor. Leaky as all get out at 20 volts, and of course just gets worse the more voltage you apply to it. And I can't check the plate to grid coupling cap because I pulverized it, but we know it was leaky. So for those who think these Philco block condensers don't go bad just because they're in a Bakelite case and sealed in tar, well, we just blew that theory out of the water, didn't we? These can and do go bad, and they should be treated like any other capacitor and gutted and recapped with modern parts. Here's the box, pretty much cleaned out. Now it's ready for the new capacitors, and I've also opened up each one of the 3 holes where we need to push our capacitor leads through to make the connections on the top side. Alright, here we are with the new caps installed and soldered and ready to be bolted back to the chassis. Now I'll say that most of the time you can do this, if you're careful, without unsoldering all of the other wires and components that might go to the rest of the radio. You just have to be careful, and then you can just, when you're done, fold it back over and bolt it down, and it'll look like nobody's ever messed with it. Okay, I'm ready to align this, and if you're wondering what this jake leg mess is, it's because my probe, for the umpteenth time, broke off from this connector, and this time when I tried to fix it, it didn't go so well, and I lost the little retainer screw on the plug here. So I got on eBay and ordered a BNC connector and a BNC test probe, and I'm waiting on that to get here. I'm tired of fooling with crusty old 70-plus-year-old probes with crumbling insulation and such. So right now I just have it jake-legged. They want us to connect the signal generator through a 0.1 microfarad cap to the grid cap of the 6A8 converter tube and set the generator to 470 kilocycles. And we have our scope connected across the speaker voice coil. That'll be our output indicator. We want to adjust each one of these 4 trimmers in the IF cans for maximum output. Now when you're working on any tube radio that uses these type of screwdriver adjustable IF cans, you want to make sure there's no B+ voltage on the screw heads for the trimmers, and the way you do that is connect your negative lead from your voltmeter, which of course is set to measure DC volts, and carefully place the positive lead and touch it on each screw, and don't let the probe tip short out to the can here, or you might get a surprise. And make sure there's no B+. And I've already done that on this, and I'm not finding any high voltage, so we should be able to proceed with the alignment without fear of sparks flying and possible things getting damaged. I have the generator set to 470, and we know it's out of alignment because I'm getting a peak. And what appears has happened here, that someone mistakenly aligned this to 455, which is the standard IF frequency, but not for Philco. I'm told the reason some manufacturers had different IF frequencies is so they wouldn't have to pay royalties to RCA for using the 455 frequency, but I don't know. So we're going to align this to 470, and then it should work a lot better. Signal generator output down, and I feel like that added interference we're getting is because of this crummy mock-up I have here with the right shielded probe. That shouldn't happen. Alright, let's do the first IF can now. Turn the generator output down some more, and I'm going to repeat the process and peak out all four of these for maximum amplitude. Alright, we're peaked at 470 now. And that's where we need to be. Okay, I was so engrossed in what I was doing that I didn't even notice that my ground lead had fallen off, so that could account for all of the interference and crap. So I'm going to go back over it yet again and double check this alignment and make sure it's spot on. Alright, watch the magic oscilloscope. It's a lot better when you have a clean signal to work with. Oh yeah. See, that's what we want to do, is find our peak. Alright, I have it peaked out as good as I can get it, and that should improve things a great deal. Sounds like our oldies station out of Tuscaloosa. I don't know that it's ever come in that strong here, so the atmosphere must be really being kind to us tonight. Yep, that's our oldies station out of Tuscaloosa. Well, we just had some Brenda Lee all alone and on this spot, and it just faded out. Classic country. The odd couple Fox Sports Radio. I hate that song.
50-50 chance of a thunderstorm, high near 84 with light winds. South-southwest winds of 10 knots on Friday night, dropping down to a low of near 70 again. 50% chance of shallow thunderstorm, high near 85. I'm Tim Livingston on WAVF 1480.
I've gotten used to it now.
Make sure you will be all right.
Top of the band's pretty hot tonight. And technically it's not even night yet. It's still daylight outside.
And see what you can do online at
Okay, that's it. And now we have a generator connected to the antenna input through a 200 picofarad capacitor. Both the radio and the generator are set to 1710 kilocycles, and they want us to adjust these two tremors on the tuning condenser for maximum. I think we need to turn the signal generator down some. Let's adjust the other one. Go back to the other one again. Crap, went past. That ought to be it, about right there. And last, they want us to adjust this tremor here for the low end of the band, which I've already done. And it seems to be working pretty good, although sometimes the audio wants to come in and out. It pulses in and out, and it was doing that before the alignment, and I think it may be a bad connection somewhere, so we'll have to check into that. Okay, I patched up a couple of spots on the speaker, so it should sound a little better now. Now we'll take a closer look at this output transformer replacement. You can see somebody did a rather sloppy job of that, so I want to make that look a little bit neater, and I'll probably just go ahead and replace this cable while I'm at it. Now that I have nice fresh new hookup wire and a new box of heat shrink tubing showed up today, we should be in good shape. Now, the burning question: did they actually solder the wires together under all of this mountain of tape on here? Well, let's unwind it and find out. Wow, wonders never cease. They indeed used solder. Although they did it kind of sloppily, but they at least soldered it. But I'm just going to cut all this mess off and neaten all this up and put some new wiring on it, and it'll look a lot better when I'm done with it. At first glance, this original speaker wire looks pretty good, but when we look at it closer, we can see some spots where the insulation is cracking, and when it starts doing that, it's time just to replace the whole thing and be done with it. Okay, our wire that enters into the field coil that also comes off of the cathode of the rectifier tube, we're going to choose yellow for that color. And then the output of the field coil, and where the B plus input to the audio output transformer connects is to the screen grid of the audio output tube. I'm going to select a red wire for that. And then our plate of the audio output tube, which connects to the other end of the primary winding on the audio output transformer, that's going to get a blue wire. So yellow, red, blue. Okay, our nice colorful new speaker cable is done. We have it soldered to the correct places under the chassis, and we have the cable tied off into a knot so it can't be pulled through the chassis and possibly break something. Also, for this operation, just like the original wire, we're using stranded hookup wire because it's more flexible and less likely to break. And for a cable that's running outside of the chassis that could possibly be handled by human hands and subjected to other vibration, we need something that's kind of flexible that won't easily snap in two. So now we need to get our speaker and make that look a little bit neater. Alright, this is not the neatest thing in the world, but I've got it done. I had to fabricate my own cable clamp because I didn't have any. Just made one out of a couple of terminals and a piece of wire. And yes, this is heat shrinked heavily to provide an extra layer of insulation. All of these leads have heat shrink tubing applied. I could have cut these shorter, but I didn't want to cut them too short because it'd make it harder to strip them and increase the chances of me ripping the leads out of the field coil and or the output transformer, and I don't want that, so this is as good as it's going to get. Still looks better than the way they had it done. So now we need to replace the wire going to the dial lamp socket. And I also had to take this socket apart and repair it with heat shrink tubing. The rubber insulator inside had gotten all deformed and was pretty much useless, so I had to replace that with a layer of heat shrink tubing, and I checked the continuity of the bulb, and it seems to be working and not shorted. If this shorts, it'll place a heavy load on the 6.3 volt filament line, as in a dead short, and we don't want that. Okay, dial light socket has been rewired and reinstalled, and I hope I'm about done with this. I don't think I mentioned this before. In case I didn't, I replaced these two resistors here. They were originally 1.5 megohms at 20%, but we all know 50% would have worked fine. I had 1.5 megohms, but they're the little small modern day resistors with flimsy leads that are too short, so I dug around and I found a 1.2 and a 1.3, and that's still within tolerance. And they have nice long leads that are plenty stout, so they're in there. There's no chance of them moving and touching anything. Alright, now let's flip it back up and connect an antenna, and I hope this thing plays. I'm about ready to put it back in the cabinet. Now, whether the radio is ready for me to put it back in the cabinet, that remains to be seen. We'll know in just a minute. Alright, we'll save the band scan until it's back together. And another thing I don't believe I mentioned, this 6R7 tube, which is the detector and first audio tube, has a weak section. One of the diode sections is weak, but the radio is still working well, and I'm not going to worry about it right now. Like I've said before, oftentimes the best test for a tube is in the circuit that it's going to be used in. And no, a 6Q7 will not substitute. I've tried one just to see, and a 6Q7 is much higher gain than a 6R7, and we had very distorted, very overloaded audio, so I may order a 6R7 just to have one on standby, but it's nothing that we have to rush out and replace right now. Yeah, it sounds like WDIA. Oh, so they did play the censored version on the radio. I actually have the promo 45 of that song, and they have the obscenity actually bleeped out of that one, so I'm sure that edit is something that was done in-house at the radio station.
anti-capitalist? Do you believe that they're Black Lives Matter? Do you believe they're just looting? Why do you think those people are out there?
I don't know what motivates the people that are tearing the place up. I have no idea what motivates them. But it's...
Probably WABF out of Fairhope, Alabama. And there's the other country station out of Gulfport, and they seem to be having a little audio trouble. Got some Phil Collins trying to put in an appearance. And we can't leave without getting some WSM in the video. Some fitting music for a radio of this age.
They may be egging on some...
.org. Donate now.
WQNO, 690, New Orleans.
Catholic radio for your community.
It's in days before... The great Midwest from Chicago. This is WGN at AM 720 on your radio and on smart devices anywhere.
Lots of noise tonight.
Calling himself the law and order president, President Trump is pressuring.
Nonviolent demonstrating here.
And the president also, in an email, he wrote...
This medical examiner is questioning. Jason has
off the nation's capital overnight.
doesn't happen here, but about 20 minutes.
45,000 people.
Wall-to-wall stations, that's what I like.